first one is probably the hardest one, okay? You kind of have to remember a little bit of organic chemistry. Where do the two carbons go?
On the sides is O.
Okay, they kind of go in the middle. They're the central part. Remember, organic compounds are a chain of carbons, and then you have stuff around it. So we have two carbons in the middle, all right? It's a little hard to keep track of the electrons, I guess. You've got, this one might be easier to kind of do 1, 2, 3, 4 electrons around each carbon. Here's the other one, 1, 2, 3, 4. Okay, there's your two carbons. What surrounds carbons normally?
Hydrogen.
Hydrogens do. So here's one hydrogen with its one electron, and so that forms a bond. Here's another hydrogen with its one electron. There's a bond. Here's a hydrogen with its electron, forms a bond. Hydrogen with its electron forms a bond. And here's the fifth one. Okay? So we've got a lot of carbon satisfied, but here we need something else, okay? The hydrogen cannot come next because then we have to bond an oxygen to a hydrogen, and a hydrogen would have two bonds.
Yeah.
Hydrogen can't do that. It can only have two electrons. Yes?
So when if we get something like this, will we look at the OH as as hydroxide or something like that, since it's not, the H's are separate?
Well, here's the deal. When you have an organic compound in OH, it's an alcohol. When you have a metal in OH, it's a base. It's kind of the difference.
Okay. But would you still look at the OH needs to be connected?
Yes. So here's going to be the oxygen. Okay? And it's going to have 1, 2, 3, 4. Let's make that a single bond. 5, 6. Okay? And then the last hydrogen is going to bond here. And it'll be right there. So there will be a bond right there. Okay? I'm going to kind of draw it like this. Okay? Now, I draw these a lot more quickly. I don't usually count up all the electrons. I know that I have two carbons. You're going to surround them with hydrogens. There's your 5. And then the OH often hangs off just as Somerset. Okay? I've been doing these a long time. Okay? But some of you have been doing them long enough to where that's instinctively what you wanted to do. Okay? If you go back and count all the electrons, they work. Okay? All right. So either way, we've got that one done. Okay? What'd you get for oxygen? This is what I really wanted to see if you could do.
The double.
Double bond. Okay?
Double bond.
Each oxygen has 6 electrons. 6 and 6 is 12. If you put an oxygen singly bonded to an oxygen, there's 2, 4, 6, 8, 10, 12. You have to stop. And this has 8, but this doesn't. So, yep, so try putting this right here, and you have a double bond. Each oxygen has 8. Okay? The carbon dioxide. Okay?
Same thing, except the C goes in the middle.
C in the middle, oxygen on either side. Remember when we counted it, there was 6 times 2 is 12 plus 4 is 16. Here's 2, 4, 6, 8, 10, 12, 14, 16.
Bingo.
We have no more electrons. Oxygen has 8, but carbon doesn't. So try moving these here, these here. We've still only used 16 electrons, but now everything has 8. And that's what carbon dioxide looks like. And hopefully you recognize that. Last but not least, our water. 6 plus 2 electrons is 8. I do remember that water's bent, and so I'm going to draw it that way.
We'd explode.
That's right. If it was linear, we'd explode because the water would vaporize like that. Right. Okay, so here we go. 2, 4, 6, 8. Is everything happy?
Yes.
Yes, because hydrogen only wants 2 electrons. Okay, so here are our molecules.
So everything in this equation has lone pairs.
Yep, it does. Okay, most things will have lone pairs. Okay? All right, so we need 3 of these. You can draw it 3 times or just put a 3 in there. We're going to have 2 of these, and we're going to have 3 of these and just 1 of these. Okay, so now what we're going to do is we're going to use the bond energies. There's a little chart in your Princeton Review Manual, but the chart we're going to need is on page 326 of your book. hopefully you'll recognize it because we used it at the beginning of the year. Okay? It's back in chapter 8, the bonding chapter.
Oh, yeah.
There's plenty of extra books, I'm sure. Okay, here's one, right here.
Oh, the book's over here.
All right. So, and you can look on with someone else. We're just going to use it for a second. Okay, the first thing, here's a good strategy. First thing you want to do is you want to identify all of the types of bonds. Brenna, what's the first type of bond that you see? Mention your elements involved, and is it a single, double, or a triple? Look up here.
There's a CH
Okay, that's good.
single bond.
There's a CH single bond, and there's actually 5 of them. Does everybody see? Here's 1, 2, 3, 4, 5 of those. Okay? Ariana, what's another type of bond that you see? What type? Single between what 2 elements?
Wait, what?
There's no fluorine.
No, I don't know the question.
Okay, look up here at our structure, or look on your paper at your structure. We've already accounted for the carbon-hydrogen singles. So what other types of bonds are in here? Okay, there's an OH, and you see it's right here. Okay, right there. And there's only one of those, right?
Yep.
Okay, so we have one of the OHs. All right. Amina, what's another type of bond? Yep. There's a carbon-carbon single bond. A lot of different bonds in this.
Yeah, multiple.
But only one of those.
Yep.
And what's the last type of bond in this molecule?
CO.
A CO, and it's a single as well. I'm just outlining them so we can kind of keep track that we've done them all. Okay, so there's one of those. All right. Now, still on the reactant side, what's the last type of bond?
Oh.
An O double,
Double,
right? How many of those do we have?
3.
Good. We have 1 in each molecule, but we've got 3 molecules.
Oh, wow.
Okay. And what I'm going to do is I'm going to kind of put a dividing line between my reactants and my products, okay? So now let's look over at the products, okay? Star, what one type of bond you see on the product side?
2 OH.
Okay, so there's an O and an H, but there's 2 per molecule, but 3 molecules. So we actually have 6 total, right? Mitch, what's the last type of bond you see?
I'm just trying to see the other particles.
Oh, could someone give me the last type of bond here?
C double bond.
Right, a C double bond O. How many of those do we have? 4. 2 per molecule and 2 molecules. So we have a 4. Okay, we're about to look up the values in the book, but let's simplify as much as we can. Is there any specific type of bond that we see on the reactant and the product? OH. How many do we have here? 1. How many do we have here? 6. So this can cancel out, and this will change to a 5. I will tell you on the AP exam, they often make this a multiple choice question. They'll have a lot of them cancel out. Because remember, they try and get you to do this without a calculator. So they're trying to minimize the actual calculations. Okay? So definitely go through the step of trying to cancel out. Okay, so now we're going to look at the chart. What's the CH bond energy?
413.
413. Now, we're going to have to assign, and we're going to multiply that by 5. What sign are we going to give? Positive. Very good. Those of you who did not remember, I want you to think about this reaction as you're breaking up all of these bonds so that your atoms are available to reform the product bonds. So we're breaking bonds. That requires energy. That's a plus. And then we'll make bonds, which is where we give off energy. That's a negative. Okay? All right. What is the value for a CC?
348.
348. We're going to give it a plus sign. Yes, it's in kilojoules, and we only have one of those. Okay? What's a CO?
358.
358, we're going to give it a plus. Okay? And last but not least, the O double bond O.
495.
Okay. And if you notice on your chart, they choose to not write O double bond O, they write O2, don't they?
Yeah.
O double bond O acts differently in other settings, okay? So it's 495. Okay, so those are our reactant bonds. What's a C double bond O? Okay, and am I going to give this a plus or a negative?
Negative.
Very good. If it's made, that energy is released. And I have 4 of them. And then how about my OH?
463.
463.
Negative.
And again, a negative. And we have 5 of those. And now we just add everything up. The way I do it, I like to assign a positive or a negative inside the parentheses and then just add it. Some people like to use absolute values in the parentheses and do reactants minus products. The reason why I don't is because the next formula we're going to learn, that's the more popular formula, is products minus reactants, and I don't want people flipping those in their head. Okay?